RHS Pre-Calculus presents Saving the World with Polynomial Functions, Episode 97, Defending Humanity, one coefficient at a time. Today we feature our exponential adventure, Awesome Powers. Our hero and his fellow agent, Foxy Function, find themselves underground next to a gigantic drill pointed directly at the Earth's core.
According to my calculations, this drill, when armed with its nuclear warhead, will drill into the center of Earth and destroy all life. We must stop it.
The override switch consists of 3 buttons. Each button is inscribed with a different graph of a polynomial function. Above the buttons, a polynomial equation is written. It soon becomes clear that to disarm the drill, Awesome Powers must match the correct graph to the polynomial function.
Graphs of polynomial functions, this could only be the work of Dr. Exponential.
Wahahaha, yes, no one can stop me. Unless, of course, you actually know how to graph polynomial functions.
Please, teach us. You'll kill billions of people if you launch that drill.
Will you let me borrow your graphing calculator for a month?
Fine, whatever. Just show us how to graph.
All right, let's learn.
In order to graph this function, we need to figure out what it's supposed to look like first.
You can tell what kind of function it is by looking at the degree, or the biggest exponent of the equation. In this case, the degree of the function is 3, since the highest power is a cubic.
Because the highest power is a cubic, we call this a cubic function. We can now use the leading coefficient test to figure out the end behavior of this function.
To begin, find the leading term, which is the term with the largest exponent. We want to look at the leading coefficient and the degree.
The leading coefficient is positive 1. Since it is a positive number, that means that the right side of the function goes upward.
It's important to note that if the leading coefficient was negative, the right side of the function would go downward.
Next, we look at the degree. Is it odd or even?
Odd.
Good. Because the degree is odd, we know that the left side of the graph falls downwards.
If the degree was even, the left and the right sides of the graph would go upward.
Right. Now that we know basically what our graph looks like, let's find the roots of our function.
We can factor x cubed minus 3x squared minus x plus 3 into x squared minus 1 times x minus 3.
We can factor x squared minus 1 into x minus 1 times x plus 1.
So our equation in factored form is x minus 1 times x plus 1 times x minus 3.
Exactly. If we set each of these factors equal to 0, we can solve them to find the roots.
Add 1 to both sides to get x by itself, and you get x equaling 1. Therefore, we know that 1 is a root.
Subtract 1 from both sides, and you get x equaling negative 1, so negative 1 is also a root.
Add 3 to both sides, and you get x equaling 3. Now we've found our last root, which is 3.
Let's plot those points on our graph.
Now let's find some more points to verify our graph.
Plug in a few values for x, and plot those on the graph. Let's solve the equation when x equals 2 and 0.
2 cubed is 8, 2 squared is 4, and 4 times 3 is 12. 8 minus 12 is negative 4, minus 2 is negative 6, plus 3 is negative 3. So now we have the point 2 comma negative 3.
0 cubed is 0. 0 squared is 0. 3 times 3 is still 0. Zeros cancel, leaving 3. So now we also have the point 0 comma 3. This is the y-intercept.
Excellent, excellent. You're almost there. Now plot those points on the graph. Finally, draw a continuous line through all your points.
Great, we've graphed the polynomial equation. Now to match our graph with the graph on the override.
That one matches! We've saved the day again, all thanks to Dr. Exponential.
I get to borrow your graphing calculator for a month. Mwahahaha! Oh, right. You're welcome. It was actually fun teaching you how to thwart my evil plans.
Yeah, baby, yeah!
The end!